Question number 2 about complex numbers. Simplify the expressions. So z1 minus z2. z1 is 2 plus 3i. z2 is 3 minus 4i. I will remove the parenthesis, which will imply to distribute this -1. I'll have -3. Most of you remember that, but a bunch of you still forget that this negative is to be applied not only to the 3, but to the other term, plus 4i. And then I'm going to combine like terms. 2 minus 3 is -1. And 3i plus 4i is 7i. Plus 7i. For this one here, I will have, of course, 2 plus 3i divided by 3 minus 4i, but to simplify a fraction means to rationalize it. That means to get rid of any radical. So I want to get rid of the I. The strategy here is to multiply top and bottom by the conjugate of the denominator. 3 plus 4i. But what I do on bottom, I do exactly the same thing on top. So for the top, the numerator, I'm going to distribute, you just have to FOIL. 2 times 3 is 6. 3i times 4i is positive 12i square. And the middle term will be 9i plus 8i, which is 17i. And here I just recognize the difference of two square pattern, algebraic identity, that I used for question number 1. I will have 3 square minus 4i, the whole thing square. Now, anytime that you see I squared, you make it -1. Otherwise, you treat it as if it were a regular variable, which means that the 12i squared will become -12. And here I'm going to apply the square. 3 squared is 9. 4 squared is 16. Please do not forget to apply the square not only to the I, which usually you guys remember, but some of you forget to apply also to the coefficients. Now, on top, 6 minus 12 is -6. So I have -6 plus 17i. And I squared is -1, so -16i squared is positive 16 plus 9, I will have 25. Now, knowing complex numbers allow you to solve quadratic equations that have no solution over the set of real numbers. Here, the set of complex number, C, will have a solution. Now, you may recognize the vertex form of a parabola with a equals 6, b equals -3, and c equals 7. So, from the vertex form, you just have to cross over operations in the inverse of PERMDAS. So you have, if you evaluate first parenthesis, then exponent and root, then multiplication and division, and finally addition and subtraction. But when you solve, you go the other way. First, I'm going to cross over the addition of 7 and negative 17 minus 7 is negative 24. Then I'm going to cross over the 6. Negative 24 divided by 6 is negative 4. Now, would I solve this equation over the set of real numbers? That would mean that there is no solution. X belongs to the empty set. But here, I'm solving over C. So when I cross over the square, so first of all, do not forget the plus or minus, I will have the square root of negative 4. Now, strictly speaking, this is incorrect. Notation, just use it as a transitive writing if you need it. But the negative inside the square root will become an I outside. And square root of 4 is 2. And finally, I'm going to cross over this addition of 3, which will become a subtraction. And here you have it.